In this lesson, we're going to learn about simplifying radical expression. A radical expression is just an expression that has some type of root on it. Either it's a square root, a cube root, a fourth root, and so on. And the way that we do that is, for example, for number one, we're going to start off by multiplying what is inside the radicals together and what's outside together. Well, there's nothing out here, so the only thing I have is what is under the radical. I have 2 times 8, which is 16. And now I need to get the square root of 16. A square root means what number times itself twice will give you 16. And the square root of 16 is 4 because 4 times 4 is 16. Let me go ahead and add some numbers here just to kind of make this interesting. So for this one, I have 3 square root of 4x times 2 square root of 5. So I'll multiply these two together because they are outside. 3 times 2 is 6. And then I have my radical sign, 4x times 5. 4x times 5 is 20x. 20 is not a perfect square root, but I can still simplify this. Let's go ahead and do a tree to break 20 down. You can do 4 times 5 is 20, 2 times 10. It really doesn't matter as long as it's completely broken down. I'm going to do 4 times 5. 5 is completely broken down, but I can keep going with 2. So that's as far as I can go. And now you need to look at the numbers at the end and see what two numbers are the same. Because I'm doing a square root, I'm doing 2 numbers. If I would have been doing a cube root, I would circle every 3 numbers and so on. So for a square root, I see 2 2's. And then this 5 is by itself. There's no other 5 to pair it with, so it stays right there. So what happens is the circled ones, which are the pairs, come out of the square root, and whatever does not have a pair will stay inside the square root. So I have my 6 here times, I have a pair of 2. You just write it down once because it's one pair, and I have nothing else to bring out. So inside my radical, I still have this 5 left. And we also have an x. I could not take out an x because I need at least 2 to be able to get it out. So now I just need to do 6 times 2 is 12. So we have 12 square root of 5x as our final answer. For number 3, I don't have numbers outside, but I'm going to go ahead and multiply this. So I have 3 times 4 is 12. Then I have x's. The product rule says when you're multiplying numbers or variables with the same base, you need to add your exponents. So my exponents here are 3, and here I have a 1. So I have a total of 4 x's. The 12 I can break down, but let's do this variable first. So I have at least 2. So I need to see how many I can take out. There's 2 ways to do that. I could draw out 4 4's. And since I'm doing a square root, I would circle each pair. So I know I need 2 x's to come out. That's the same thing as saying x squared. Another way I could have done this is divide your exponents by your radical. So this is a square root. There's an understood 2 to be here because a square root is every 2. So I could have just done 4 divided by 2 is 2 to get my x squared. That's important, especially if I have like 40 x's. You don't want to draw out 40 x's and start circling them out. Now let's break down our 12. The 12 is not a perfect root, so I can break that down. That's 2 times 6. 6 is 2 times 3. I see here a pair of 2's. This will come out. The numbers always go in front of your variable, so I'm going to bring it right here in front of this. I have a 3 left over, so that's going to go inside. I don't have any more x's because 2 went into 4 evenly. So this is my final answer. For this last one, I have a 4th root. So I'm going to go ahead and divide my exponents for this one. I'm going to divide 8 divided by 4. That is an exact 2. So that means x squared will come out. Here I see 7 divided by 4. 4 does not go into 7 evenly. So let me go ahead and set up my root because I know I'll have a remainder. Okay, so let's do long division on this one. 4 goes into 7 one time. 1 times 4 is 4. Subtract and you get 3. This is how many times this comes out. So this is how many y's will come out. This is how many y's stay in the radical. That's because if I drew out 7 y's, 1, 2, 3, 4, 5, 6, I need one more. Our fourth root, I need to circle every 4. So I have one set of 4. I don't have enough for another set. That's why 3 y's have to go back inside. And then I have one set of y's that will come out. I'll just stick that right there. So 4 goes into 7 one time with a remainder of 3. That's why that is over there.